on the video though, so other people could get it, Yeah. So question was, let's say we have a point, right? And this point was like -5, 10, right? So we want to know what is the vertical line, passing the equation for the vertical line, right? So what would that be? So this is my x-axis, this is my y-axis. I'm going to plot this point. It's -5, 10. So I come across 1, 2, 3, 4, 5. Then I go down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So right here, here's the point. Now, this point is -5, 10. And I want to know an equation for a vertical line up and down, a vertical line going straight through the point, right? A vertical line. So the vertical line went through which axis? The x-axis, right? So my equation would be what? It would be x is equal to what number did it go through? -5. And that's it. That's the equation for the vertical line passing through that point. Let me ask you, what's the horizontal line passing through this point? What is it? Not just 10.
Oh, I equals.
Y equals 10. Very good. This is the horizontal line passing through. And this is vertical. Cow. Okay. Another way I like to think about it, right? When they ask for the vertical line going through it, right? Vertical starts with what letter in the alphabet? V, right? And if you flip V upside down, what does it look like? Like this, right? You see how that looks like an X, right? If they, right? So now let's say they ask you for the horizontal line. Hmm. Exactly. So check this one out. Let's say they ask you for the horizontal line, right? So you know how the horizontal is like this? If you flip it upside down, what does it become? Like a Y, right? So that's how you know this Y equals whatever. I don't know. Or the sunset, horizontal. Yeah. That's another nice little trick right there. Hmm. Fun, right? Any other questions from anybody? Which homework? All of 15. Which one was homework 15? I don't remember that one. Let me see one. And we'll jump into today's lesson. Today's lesson is like really, really easy. You guys are gonna love it. Hi, how are you? It's your birthday. Happy birthday. Wait, it's your birthday?
No, no, her birthday.
What? Happy birthday. See, I should have gave you the test today. That would have been a perfect birthday present. Oh man. Hmm? Which one?
Who's gonna help me with this? Because
The formula sheet you keep.
they got it.
They got it wrong? Let me see.
I'm not the only one. Even ChatGPT got it wrong.
Which one?
The one that I got wrong.
This one you just plug it in like the way you've been doing it.
This one was +6.
Mm-mm.
I put that on ChatGPT, it's not giving me no. And then this one is giving me the same answer, which is simplifying this 3.
No, that's right. You're good. You got that. It's only the ones with the little X. Yeah, so like this one, just plug it in. This one. This was good. That was straight. Just that was wrong.
The meeting.
Actually, I think you got it right now. Right. So long story short, it's like when you have
Two of them in the middle,
You add them and divide by two.
divide by how many numbers there?
Right. That's
So
it.
there's three.
It always
It
be
would be
two.
two.
Yeah, two of
Yeah,
yeah.
yeah.
And that's it. So
Okay.
you almost there. I got you. I'm gonna give you a whole breakdown of that as an announcement tonight with the videos.
Staying after class?
Not today. No, that was yesterday. Yeah.
I mean, he was on Zoom, but I didn't even get on.
Yeah. Right. We was there till 5 o'clock. We was chilling.
Oh, yeah, what?
Yeah. Okay. 4:40 on.
The chapters for tomorrow's test. What
Yeah.
chapters is that tomorrow?
So
Graphing.
I'm gonna tell you 6, 5, 4.
There's points too.
Yeah, and then the algebra stuff, like the equation of a line and like
The slope stuff.
slope stuff, that stuff. Yeah, literal equations.
Leave like
Yeah.
one example of each. So I can go
I
over.
got you. The homework. Just do the homework. Yeah, you know. Yeah, that's it. Mhm. Mhm.
So this is gonna have it, I wanted to show you.
Mhm.
I'm gonna show. Oh God, I already know. If I have that, they'll accept the best.
I'm gonna type it up for y'all as an announcement tonight.
Where the more about to do disability stuff?
So that's in Low Hall.
Not low.
Two,
Let me read the same.
is it 213 or 219? It's Low Hall to. Ooh, I should know.
That's the first building, right?
Yeah.
So what do I?
By the way, today's pantry, in case y'all ain't remember. Yeah. And tomorrow too. So you just tell them that you want accommodations, that's all.
And do they have people to read out the prop?
That's an accommodation, yeah. Yeah. When I was taking my permit from for my license, I did that, you know?
Didn't you mention the grading of the test? The test I gave?
Not yet. I have it right here. I'm gonna try and do that like real quick. Okay. I feel like it's 211, but I'm gonna tell you right now. I'm Googling it. Uh-huh.
The dean of the school, the principal, are they, are you guys supposed to have an X amount of chapters you go through every week or every month? Or is this up to you?
It's up to us. We have a syllabus to follow, what we gotta cover. Yeah. So yeah, low hall 211. That's the one. Yeah. Yeah. Mhm.
You're be rushing too fast through the chapters.
You think so? You think this was slow? Okay.
At least not for me.
I'll try and slow it down. I'm not sure.
We should do it as chapters, each quiz.
Oh, with the test, yeah.
Yeah.
I feel you on that. This one has mad topics. Mhm.
You should do like what we're learning, and then Thursday, you should give us like a little test, like with 3 questions. I know it's.
Or like a quiz. Yeah, we could do
Like
that.
a mini quiz that doesn't count to see if we're understanding what you're saying.
We could do that.
I think that would be easier and it'll help us leading up to the actual.
Yeah, because if this discourages people a lot, like when you get a grade and you think you studied and I went to tutoring and I got it wrong, that's very discouraging. So it makes me feel like I don't want to do it.
Okay. No,
And it's
it's
not fair
okay.
because I'm using the resources from the school.
I got
You
you.
get what I'm saying? And it's not your fault. It's not your fault at all.
Yeah,
It's just,
I got you. We'll work it out. It's not the end of the world.
yeah.
Mhm.
No, I'm.
Mhm. 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 Really? Every time I go is dead. Like I see nobody there. Yeah. What time you be going? What time you go? Cause maybe I should try and go there. Okay. So I was just there right now. It was dead. Oh yeah, Zoom can get packed. Yeah. But not when I'm there on Saturday. Nobody's there.
How many there's rooms outside?
The whole day from 10 to 3. Yeah. Yeah. But nobody comes though. Yeah. Yeah. Nah, nobody's there. Yeah. Yeah.
So that's why
Right.
with the probability.
Yeah. Yeah.
Different tutor, because it's like, this one, whatever she can click, whatever she can click, whatever she can kind of click, then. So
That's
it's like
good.
overall, you know.
That's
And
good
then,
though.
like, this-
Yeah. I feel you. I feel you. I feel you. I feel you. Yeah. All right, let's finish up this topic real quick. Real quick. This gonna be a quick and lovely class. Nice and easy.
William.
I forgot his name. I just say.
You think so?
We still in together. See him when I go inside.
You think so? He don't even be coming no more.
Like, you the child. The test not very well. I wanna lose people. You better know how to do this, Mr. Money.
I mean, I posted it online, didn't I? All right. Yeah. But I'm gonna make another post though. Yeah. Mm-hmm.
That's crazy.
I got you.
He ain't crazy.
But the whole process.
But I showed you multiple ways to do it, so you got options.
Yeah, I'm just, like, what I did. Remember that formula, they go.
Yeah. Sorry, I just want to finish this topic up real quick, all right? So look, many times, hold on, let me move this real quick. Move this over here. Yeah. We're just building off what we did yesterday. We only have a little bit left to go, right? So many times we are asked to compute the probability of a range of successes. For instance, in a binomial experiment with n trials, we may be asked to compute the probability of 4 or more successes, right? And you remember we use a table to get that. We just add up all those numbers that we need off the table, right? So how common English expressions such as 4 or more successes translate to inequalities involving R, right? So this is what Angelina was asking us, right? So let's say I have an expression 4 or more. That means what? R is greater than or equal to 4. Say I have an expression that says at least 4 successes, right? At least 4. So that's R greater than or equal to 4 as well. No fewer than 4 successes. That's also R greater than or equal to 4. Not less than 4 successes, right? That's also R greater than or equal to 4, right? So that means it's going to be R equal to 4, 5, 6, etc., right? Let's look at R less than or equal to 4. So that means, so some ways that could be worded: 4 or fewer successes, right? At most 4 successes, no more than 4 successes, or the number of successes does not exceed 4, right? These are some other ways that the question could be worded, right? To let you know that you're doing 4 and less, right?
You're gonna give us that and want us to write it like that?
You don't have to write like this. You could write it in English like this. I need you to know what it means. Yeah.
Right, what he needs.
Yeah. So if I say at most 4, that means I'm talking about 4, 3, 2, 1, 0. Right?
Like the most is 4.
Right.
Right.
Yeah. Exactly. Right.
That's the definition.
Right. Another way we could say this also, let's say we have more than 4 successes. So that's R greater than 4. That does not include 4. So I'm talking about the numbers bigger than 4, 5, 6, 7, 8, etc., right? The number of successes exceeds 4. That's another way to say it, right? That means that I'm talking about the numbers bigger than 4, 5, 6, 7, 8, whatever, right? Next, we have less than 4. So if I say fewer than 4 successes, right?
Wait.
So that's R.
Does not exceed, or exceed meaning passing for it?
Right. It doesn't pass forward. Right.
Oh.
But includes 4. Right. So that's gonna be like 4, 3, 2, 1, 0.
Oh.
Yeah, yeah. But if I say fewer than 4 successes, that means the numbers that are smaller than 4, but not including 4.
Yeah,
So 3, 2, 1,
you're
0.
always gonna include the number of eight.
Sometimes, depending on which wording I'm using, right? Or the number of successes is not larger than 4, so that would be like 0, 1, 2, 3 as well. All right. Questions on this? Anybody?
So when we doing this in the homework, it's gonna be with the wording.
Or it might be with the inequality and you have to give it the
You have
wording,
to
whatever.
pick up.
Yeah, either way.
And that
Yeah.
are
Mm-hmm.
less than 4 underscore 4,
Mhm.
less than or equal to.
Less than or equal to 4. Yeah.
That's what that means.
Yeah.
It's the bigger number. But
Yeah.
the smaller number.
Yeah, that's true too.
The
Yeah.
small-
The bigger number. Yeah, yeah. Yeah. That's that. There's a homework question that's gonna be on there. That's gonna help you with that homework question. Mhm. One last paragraph.
Oh, a little more.
You should,
What would you get?
because that's exactly what I do. You might.
Wow, you didn't even tell us that. You wanna see me again next semester, that's what it is.
That's true
You're not
too.
gonna be here, tell her she's not.
She's gonna be in the nursing department. All right. So interpretation. Often.
Everything else is but.
Good. I know.
What's that mean?
I said, look, often we're not interested in the probability of a specific number of successes out of n binomial trials. Rather, we're interested in a minimum number of successes, a maximum number of successes, or a range of a number of successes. In other words, we're interested in the probability of at least a certain number of successes or no more than a certain number of successes, or the probability that the number of successes is between two given values. For instance, suppose engineers have determined that at least 3 of 5 rivets on a bridge connector need to hold, right? If the probability that a single rivet holds is 0.8 and the performance of the rivets are independent, then the engineers are interested in the probability that at least 3 of the rivets hold. So notice that the probability of R greater than or equal to 3 rivets hold is equal to 0.943, while the probability of R equals 3 rivets hold is 0.205. So the probability of at least 3 successes is much higher than the probability of exactly 3 successes. Safety concerns require that 3 of the rivets hold. However, there is a greater margin of safety if more than 3 rivets hold. As you consider binomial experiments, determine whether you are interested in a specific number of successes or a range of successes, right? The question will tell you, right? And then this is just for your information real quick, sampling without replacement. So we use the hyper geometric probability distribution. If the population is relatively small and we draw samples without replacement, right? Meaning that we don't put them back, right? The assumption of independent trials is not valid, and we should use the binomial distribution. The hypergeometric distribution is a probability distribution of a random variable that has 2 outcomes when sampling is done without replacement. This is the distribution that is appropriate when the sample size is so small that sampling without replacement results in trials that are not even approximately independent. All right? Cool. This is a continuation from yesterday. Yeah. So it's like a binomial distribution with a really, really small sample, right?
So several that we got on the front of the sheet, there's something small.
It's something smaller. Yeah. Long story short, after the final, if you're interested in it, come ask me and I'll show you examples of it.
After the final,
Mhm.
sorry, see me after this.
Why?
I'm done with the class.
Oh. So y'all saying that if y'all was in pharmacology, y'all wouldn't come see me or nothing?
Wait,
If they let me.
what?
Mhm. The only thing I like more than money is drugs. Cause I'm not your major. That's why. Because I'm not your major.
But then we going on.
Math, computer science, yeah.
So
Huh?
it's not.
If they let me, you know, I'm begging them to, you know.
Sounded like you actually like measured medicine and all that.
Exactly. But I mean, you're not really, I guess you are measuring it to a certain extent. Like the doctor is making an order, right? Give this patient this much of medication, period, right? And then for you're trying to calculate how much medication to give them based on what you have available, you know? So like the hospital has a storage of medication and the doctor said give them this much medication, but the doctor didn't tell you how many pills to give them or how much liquid to give them. You figure that out. You know, you just know how much medication that they have to receive, you know? It's like it's a unit conversion. Yeah. Yeah.
So like they
Hmm.
put the medicine on a scale, just.
Exactly. Yeah. For you, it's a little bit easier because it's just a unit conversion, you know? But like it could get complicated. It's not. And to be honest with you, like if we talking about real life, like forget like textbook, like real life is mad simple. Like there's a computer right there that does it all for you. Mhm. Yeah. Matter of fact, in the hospital, take it up a notch, right? There's this what do they call this again? Pharmacy. They have like pharmacies in the hospital that actually do the measurements for you. Just be like, here, you know. I mean, you still got to check them. Be like, all right, this looks like the right dosage, the right amount. You know, you still got to check them. But other than that, good to go. Hmm. That's like what the medical lab tech people do. Yeah. Like the jobs itself is not that bad, you know. The schooling for it is hell, but the jobs are not bad. All right, so let's finish this up. All right. Additional properties of the binomial distribution. Yay. So, graphing a binomial distribution, any probability distribution may be represented in a graphic form. How should we graph the binomial distribution? Remember, the binomial distribution tells us the probability of R successes out of N trials. Therefore, we place values of R along the horizontal axis and values of the probability of R on the vertical axis. The binomial distribution is a discrete probability distribution because R can assume only whole number values such as 0, 1, 2, 3, etc. Therefore, a histogram is an appropriate graph of a binomial distribution. All right, so procedure, how to graph a binomial distribution. You want to place R values on the horizontal axis and place the probability of R values on the vertical axis, right? Construct a bar over each R value extending from R minus 0.5 to R plus 0.5. And the height of the corresponding bar is the probability of R, right? Okay, long story short. Remember we talked about histograms, right? And we talked about two of them, right? There was frequency histogram and there was relative frequency histogram, right? For the binomial distribution, it's a relative frequency histogram, period. That's it. That's what they're talking about. All right. Well, let's look at an example real quick. All right, so the graph of a binomial distribution, right? A waiter at the Green Spot restaurant has learned from long experience that the probability that a lone diner will leave a tip is only 0.7. During one lunch hour, the waiter serves six people who are dining by themselves. Make a graph of the binomial probability distribution that shows the probability that 0, 1, 2, 3, 4, 5, or all six lone diners leave a tip. All right.
This is basically what we did yesterday, right? That was like the last part of it,
Mm-hmm.
the last part.
Yeah.
So what are they trying to say?
So we're just gonna draw the distribution real quick. Because of time, I'm just gonna show you guys what it is, right? So this is a binomial experiment where n is equal to 6. Success is achieved when the lone diner leaves a tip. So the probability of success is 0.7 and the probability of failure is 0.3. So if n equals 6, p is equal to 0.7, and q is equal to 0.3. We want to make a histogram showing the probability of our successes when r equals 0, 1, 2, 3, 4, 5, or 6. It is easier to make the histogram if we first make a table of R values and corresponding probability of R values, which you see in the table right here, right? And then we'll use table 2 of the appendix to find the probability of R values when n equals 6 and the probability is equal to 0.7. So we have our R's here, 0, 1, 2, 3, 4, 5, 6. There are probabilities of R here, and we're just graphing them. Boom, boom, boom. And that's it. All right.
X is 6, right?
X is these numbers, 0, 1, 2, 3, 4, 5, 6.
So when you get that problem, you have to do this graph.
Yeah. Yeah.
Write it down.
Mm-hmm. You're not gonna get a problem like this,
How
really.
you get this?
So you can use the formula individually to get them, or the calculator, or you can just take them from the table. Whichever is easier.
What do you mean? I don't get it.
X is the R value.
I don't understand.
So either one of those we put into the calculator.
Mhm. You can either do them individually, or you can do them added up together. What were you gonna say?
I don't understand.
So long story short, you have a number of successes, and you're finding the probability of each number of 0, 1, 2, 3, 4, 5, 6, and you're graphing it. The height of the graph is the decimal numbers that you have here.
Don't mind me.
But don't worry, this is just knowledge for you.
It tells us the answer. You already gave us the answer with P.
Mm-hmm.
It's just we're gonna round it up.
Mm-hmm.
So what are you saying here? That we want to do a graph, like the purple one?
No, just explaining it.
Is that I can't see because everything's
It's
up
blurry.
there, then down there, and not together, so I'm confused.
Like
I
what
can't see the
the
problem right now.
what the problem?
Yeah.
This part?
But our histogram is not perfect.
Mm-hmm. Mm-hmm. Go ahead. Let's continue. So to construct the histogram, we put R values on the horizontal axis and probability of R values on the vertical axis. Our bars, mhm, will be 1 unit wide and will be centered over the appropriate, R value. The height of the bars over the particular R value tells the probability of that R, all right? The probability of a particular value of R is given not only by the height of the bar over that R value, but also by the area of the bar. So each bar is only 1 unit wide, so its area is equal to height times width, equal to its height. Since the area of each bar represents the probability of the R value under it, the sum of the areas of the bars must be 1. In this example, the sum turns out to be 1.001. It is not exactly equal to 1 because of rounding error. All right. That's it.
So basically, it shows that, let's say 4 is the highest one, right, because it's R.
Mhm.
It's just explaining to us that this is the probability for this number is higher.
Mhm. Exactly. Mhm. It's like graphically showing you that.
The R equals negative R.
It doesn't.
It doesn't.
It doesn't. It's something different. Yeah. I got you. So the graph of the binomial distribution is symmetric no matter how many trials we have. All right. In the next section, we're gonna look at really, really large, like n sizes. All right. So here's a question. What does the graph of a binomial probability distribution tell us? Let's look at that. Hmm? For real. Mhm. It'll pass. It happens around this time every day. Yeah. But you see like 6 o'clock, 7 o'clock. Oh my gosh. No, no, I'm good. Yeah. But this time is like, yeah, yeah. It's like my day is bimodal, you know. Like when I wake up, I'm good, and then 2 o'clock, and then like nighttime. Yeah. Yeah. All right, so what does the graph of a binomial distribution tell us, right? Consider a binomial probability distribution with n trials and probability of success on a single trial p, right? The graph of the distribution tells us that the probability of r successes for each r from 0 to n. If the graph is mound shaped and symmetrical, the probability of success p is close to 0.50. If the graph is skewed right, the probability of success is less than 0.50. The more skewed right the graph, the closer the probability is to 0. If the graph is skewed left, the probability of success is greater than 0.50. The more skewed left the graph, the closer of p is equal to 1. Cool. All right. Now that we got that stuff out the way, let's talk about what I really, really, really want to talk about. This is going to be really, really simple. This is the last part of your homework. The last part. Last section, last part. So we're going to be talking about the mean and the standard deviation of a binomial distribution. All right. So two of the features that help describe the graph of any distribution are the balance point of the distribution and the spread of the distribution about the balance point. The balance point is the mean, mu, right, of the distribution, and the measure of spread that is most commonly used is the standard deviation sigma. This means mu is the expected value of the number of successes. So for the binomial distribution, we can use two special formulas to compute the mean mu and the standard deviation sigma. These are easier to use than the general formulas in section 6.1 for mu and sigma of any discrete probability distribution. All right.
Is the part where are we?
Yes, we're getting into that. That's the next chapter. Yeah. Empirical rule. Yeah, that's the next chapter. Yeah, that's gonna be good though. We're kind of like building up to that. No, no, you're good, because I need a minute. So we jumping back to formula sheet again, all right? So straight from the formula sheet, right? This is the procedure of how to find the mean and the standard deviation, right? Or the expected value of standard deviation. So how to compute mu and sigma for a binomial distribution. So mu, also known as our expected value, is equal to n times p, right? N is your sample size, p is your probability of success. N times p, that's the expected number of successes for a random variable r. Sigma, your population standard deviation, is the square root of n times p times q, and that's the standard deviation for the random variable of r, where r is a random variable representing the number of successes in a binomial distribution. N is the number of trials that you have. P is the probability of success on a single trial, and Q is equal to 1 minus P, which is the probability of failure on a single trial. Okay? Questions on this? We good? All right, so take a look at this. I'll show you. All right, so let's say that I want to compute mu and the standard deviation, so the population mean and the standard deviation, right? Let's compute the mean and the standard deviation for the distribution. Example 6 that describes the probability of lone diners leaving tips at the Green Spot restaurant. So my n is 6. My probability of success is equal to 0.7, and my probability of failure is equal to 1 minus the probability of success, which is 1 minus 0.7, which is what? All right, so it's going to be 0.3. Right. So anyway, no. So the first thing that they're asking me to find is the expected value, mu, right? Mu's equation is n times p. What's n? Times 0.7. Good. And that's it. 4.2. That's the answer. That's mu. Mu. Sigma, this one, is equal to the square root of n times p times 1 minus p. So just keep going. This becomes square root. Mhm.
6 times 0.7 times 0.30.
Right. Do a little bit of math on this. What do you get?
1.1224972.
Let me see. I got the same thing. 1.12249 something like that. Questions on this? Go ahead. Basically, your question is going to give you, your question is going to give you a question like, give me the expected value or give me the standard deviation. You just have to know to use this formula, plug it in, boom, 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 and that's it. Uh-huh. Hmm?
The homework is on the budget if I can.
Mhm. It's going to ask you what is the expected value, what is the standard deviation. You just do it. That's it. Mhm. Well, no, expected value is mu equals n times p.
Then all the
The standard deviation. That's it.
how would this be on class? The way it's more.
It's the actual homework question. I just copy and paste it. That's all.
Yeah, but everybody got different. Shit.
Whichever one is the easiest one. What's the one I copy and paste? All right, so the mean mu is not the only, excuse me, is not only the balance point of the distribution, it is also the expected value of R. Specifically, in example 6, the waiter can expect 4.2 lone diners out of the 6 to leave a tip, right? So the waiter would probably round the expected value to 4 tippers out of 6. Mm-hmm.
Six, right?
Yeah.
Eight is 4.2,
Mm-hmm.
then the Q would be. One minus P equals 1 minus 0. Okay, 4.2, right?
Mm-hmm. You can. So I'm looking at the rest of this and I kind of don't want to go any deeper than this.
Wait, should we solve this?
No, it is solved. That's the answer right there. Yeah. All right, so you see, if they ask you for the mean, n times p. They ask you for the standard deviation, square root of n times p times q. This is on your formula sheet. You do not need to memorize it. Let me show you where it is. It's in chapter 6. Let me copy and paste it real quick. We will pick back up with the rest of this lesson on Tuesday. You guys can do your homework for right now. While I do two things for you. This is on the test tomorrow. Mhm. This is just adding on to what was there before. So just to show you, right, that this is on the formula sheet, this is directly from the formula sheet where it says chapter 6. All right. So here's the formula right here, where it says mean mu is equal to n times p and standard deviation sigma, n times p times q. This is q. All right. So that's why you see in mine, I don't really have a q. I do 1 minus p. That's the reason why. What is my computer doing? Come on, man. Okay, you see in my formula, I just do 1 minus p, right? That's where I'm getting it from. I don't know what's up with my computer right now. It's like not cooperating. Okay. Questions? Anybody have any other questions? To real life? So when you have a binomial situation in real life, you could use this. Like, say, all right, the textbook tells you, right, to do a intradermis injection, right? You do 90 degrees, right? Maybe there's a better angle that you can do an intradermis shot with something, right? But you don't know if it's gonna work or not, right? It could either work or not work. That would be a binomial distribution question, just like this. Mhm. All right, so let's talk about the test then. I got you. Generically, all your homework, right? But more specifically, I'm gonna tell you. Yeah, it's the same thing that we did in office hours yesterday.
The days.
Yeah, you got today. Yeah, yeah, that's what I'm gonna give you. Yeah, I'm gonna do that announcement tonight. All right. Like with all the videos and all that, like the topics is gonna be on it. All right. But just real quick, right? What's gonna be on the test tomorrow, right? So first topic that you have, hold on, I forgot my pen. The rainbow. Okay. Yeah, it's the same ones. Yeah, yeah. So compounds, what's it called? Compound probability, something like that. So that's the and the or questions. Yeah, right. So that's the first topic. Yep, contingency tables, that's gonna be on there too. Contingency table. So that's the one where you had like the grid, and then I ask you like, oh, what's the probability of like Democrat? Or what's the probability of like yellow? I don't know, whatever, right? And you just give me the answer. We didn't do one yesterday, but we did it in the past, right? You'll see it in the homework. It's a grid. Yeah, I got you.
Yeah. The whole bunch, but
Mhm.
it goes back to. Yeah.
No, no, no. Contingency table is the one that's like if I have like black, blue, and I have like tall, short, right? And then you have like some numbers in here, right?
Oh.
And then you have the row totals over here, that thing. Right, that thing. Yeah, that kind of stuff, right? And then let me see what else. The binomial distribution, that'll be on it, right? That's what we just yeah, yesterday and today. Scatter plot will be on there too. Hold on. Scatter diagrams or scatter plot, whatever you want to call it. Yeah, the one with the dots and as X is increasing, Y is increasing, that stuff. All that good stuff. Um, Solving equations will be on there. Solving linear equations, more specifically, right? So not for today. Yeah. Well, no problem. Uh-huh. Linear equations, no problem. I got you. Got you. No problem. No problem. No problem. So solve literal equations, literal, I think. Equations. Real quick. Graph a line. So like the equation of a line, y equals mx plus b, that kind of thing.
We did look at the graphs.
Like, no, you're gonna give me a graph.
We didn't have to make the graph.
Yeah, yeah. There's like two graph questions: the scatter diagram and then the equation of a line.
And question where we have to
Mhm.
take information from a graph and give it to you.
No, that's mad complicated. Mhm. Solving inequalities, linear inequalities.
Are you gonna post that right after?
Mhm. You're welcome. I see you. Right. So solve linear inequalities, something like that. All right. And then like, graphing an equation, when I give you 2 points, you find the slope, the y-intercept, and graph it for me, that kind of thing. Give me the graph of an equation that's passing through a particular line, that type of question. Literal equations, it's like if I give you like equation and you just solve for a variable, that's a literal equation. And that's it, that's the whole test. Just these topics here. So if you want to go to ChatGPT and say, give me a question like this, go ahead. If you want to cheat, you could go ahead and do your homework because I just copied and pasted the homework questions on and made the test. Up to you. Good stuff. You're welcome. Any other questions? Or are we good? All right. I need time to download this, so I'm gonna turn this off. Is that okay?
Yeah.
Awesome.